All right, everyone, welcome to Physics 1405. This is our first, basically it's a homework help session, but I know that you guys are all starting out. We're here together this week and there's a lot to figure out. So I've had a lot of emails. We've had a lot of questions. We've mostly tried to communicate on Canvas, but I am happy to answer questions here with you guys today, talk about the homework, talk about any concepts you find difficult. This is basically a resource for you and it's going to be guided by your questions. So I'm going to be doing screen sharing here so we can look over our course, our Canvas, our Wiley resources, and then I'm also going to be trying to use just paint as a whiteboard so we can talk about equations of problems if we need to. So I'm going to begin that and then we will basically open it up and let you guys start with your questions. I will also suggest, does everyone know how to use the chat? If you mouse over the bottom of your screen, the chat opens up. If you can all put your names there, I do like to keep track of attendance, you guys that have been here and taken that effort. And, you know, later on, you know, you guys do know we have a bonus point system. We may decide to incentivize people, but we will always let you guys know in advance what's worth bonus points and what's not. So feel free to just write your name in the chat so I have it. And I will begin with the screen sharing so you guys can see what I can see.
I have first, can I have question?
For just a moment so we can get this set up so people can see and then we will begin. All right, so can you guys see, basically it's going to work like a whiteboard here?
Yes.
Okay, great. And I will. All right, so what's our first question? We have people ready to jump in.
Actually, I don't know how I found homework in the Wiley.
So when you open up the Canvas web page, do you see there's little green boxes? Those are what we call our modules. And you see at the top it says start here.
Okay.
And then there's one that says student help and resources, and underneath that, in fact, I can pull this over so we can look at it. Just a moment, I've lost the window. Okay, so you guys can see the Canvas now. We're in announcements. If you just go home, you see we have orientation. So orientation 3, Introduction to Wiley Plus, is a Wiley Plus assignment. So if you click on that, and you will need to, and it says load it in a new window. So if we do that, now mine is going to load for me because I've signed up and everything. So initially, you won't automatically have access. You need to let the system, this is actually a separate website run by separate people. So you will need to do all of the initial signing up for an account and everything. But any Wiley link in the course should bring you to that point of where it will ask you for credentials and you need to say, I need to make an account and everything like that. Does that make sense?
Yes, thank you.
Okay, great, thanks. And also things like this, you guys, I have never gone through this from the student view. So if anybody wants to chip in with what it looked like for you, that's great, but it sounds like we answered the question. Any further questions? I know that we are probably going to have homework assignment questions come up.
I have a question.
Uh-huh.
Was this textbook or the Wiley provided, like, was it paid for through our fees, or was that something that we had to pay for?
Yes, so they have what's called the first day system. It's an access thing where they actually charge the price through the class, and then it's supposed to all be extra imported and integrated. This is the first time I've ever seen it, so I actually had a bit of pain setting it up. But yes, you all are supposed to basically, once you click the link to access the homework, you're just supposed to be able to basically, you do have to set credentials, but it is supposed to work for you.
Okay, because I just did the 14-day trial.
Mm.
I just pressed that, and because I never figured out how to actually get my access code and everything. Is that something that you know how to do, or should I just contact support?
Yeah, I don't have any expertise. I do know that we've referred some people, and there's been some comments. If you look at the comments on the announcements, different people went through different things. There was a particular day where everyone was getting asked for an access code, and I contacted my support, and they changed the class settings, and people later in that day said it changed for them. So if you signed up earlier than the morning of that day, and you could just read through the announcement comments and kind of see how it was for everyone. You signed up earlier than that, you may run into difficulties that changed later on. But to change, I think now you might need to change your account, and you probably need to talk to Wiley support in order to do that.
Okay, thank you.
Okay, any other questions on the course? Let's go ahead and get these course and navigation questions out of the way. Did anyone else have any trouble? I know that most people have gotten through all of that and are making it work, but.
I have question about the video you put for us.
Which one?
We should write about that. 3 paragraphs.
Oh, the discussion
Power.
question assignment?
Yes, it's power.
Yeah, so you're looking at the discussion question assignment for week 1. And what about it?
We should write about power.
Powers of 10. Yeah.
Okay.
Yeah, so go ahead. What's the question?
No, it's about power and scientific notation.
Mm-hmm.
Okay. And scientific notation is 10?
Yeah. So that particular video is just trying to illustrate the scale of different things in existence. Physics covers a lot of the very, very small to the very, very large. And the assignment basically, this is kind of prerequisite stuff. You need to know how to use scientific notation, and you need to know how to do unit conversions. To basically, we're going to be using that, just kind of assuming that you can do it for the rest of the course. So I think that is, and I have not designed all of these assignments. So some of these were designed by Collin College kind of as an entity, some of our full-time staff. And so all of these are not necessarily sourced directly from me, but that's the point of the video. And our first lab assignment that is due on Monday also goes over some of those things and expects you guys to know scientific notation. And the basic materials for the lab should also explain that if you're less comfortable with it. So is that something like, do you have a specific question about it, or? In regards to scientific notation generally?
I need a little bit explain about scientific notation and power a little bit. Exactly. Okay. For example, 6,000, and just I read about that. What is that, for example? I don't know.
Okay.
I don't know.
All right. So if you look, lab 1 is opening in a little tiny window for me right now. Can you guys see this? If you click on lab 1, which is part of our module for week 1, you'll see some videos here about the metric system, unit conversion, scientific notation, this video right here, this video right here, and significant figures and powers of 10. So are you able to find that? If you just go, let it load. So my navigation's a little weird. You see down here, week 1, lab 1. If you go to that, all of those videos are linked, which are over those topics. Does that look helpful?
Yes, thank you.
All right, wonderful. Any other, do you guys have specific questions like on homework assignments you got stuck on, anything like that?
There's some comments in the chat box. I have questions on lab quiz for numbers 9, 20, 22, 23, and 24. And then Mackenzie added a couple as well. This is Jasmine. Hi, Professor Sutherland.
Howdy. Okay, so if people, just so I'm, I've got a lot of different navigation happening right now. If you guys can kind of bring the topics, like answer a question that I can ask a question I can just answer without having to go dig in and find out what the question was. That will help us go a little bit faster.
So you want me to read it?
Yeah, like, go ahead.
Oh, okay. So number 9, this one's really simple, but I'm just wondering why the system counted it wrong. So in order to calculate area, it's going to be length times width, right?
Yes.
Okay, so in this particular question, the length is 4 and the width is 3. So as an answer, I put 12, but the system marked it wrong, and I was wondering why.
Okay, so it was probably asking for units. Did you include your units in that? And also, it was multiple choice question?
No, this one was fill it in. It wasn't multiple choice.
Yeah, so and I believe there's a thing that starts explaining units that are just like, oh, if you go to the store and ask them for 6 of flour, you're not going to be able to get anything. They won't know. So I think that they're trying to emphasize to use units. So if you enter 12, they also want to know 12 what. So I believe in that case it was meters cubed or something. The other thing is what units were asked for, were given in the problem, because there might also be a conversion that you have to do. So what exactly does the problem say?
The area of a rectangle is calculated as length times width. A table has a length of 4 feet and a width of 3 feet. What is the area?
Okay, and does it not mention specific units?
No.
Okay.
And then on that particular problem, I had put 12 feet, but then it prompted me that it didn't want any like alphabetical notation on it. Yeah, so I just ended up putting 12. So I was confused.
All right, that's one I will probably have to navigate to that and see exactly what it's asking for and what it wants. Okay. Go ahead and send me an email. That's one. If the problem was not specific in what it wanted, I can reset that for you and let you have another go at it. But just in general, those ones, if you guys feel like you understand the concept of the problem and you think you're just having trouble with the system, especially this week while we're getting used to the system and figuring out what it wants, go ahead and send those to me by email, and I will just reset your tries and give you a hint of what it's looking for, and which that should clear up any issues that are just due to the systems and the navigation.
Okay.
And about that 12-foot question that we just talked about. I also put 12 feet at the first attempt, and I went back and looked at it. And I think the last 2 answer questions were like the meters squared or whatever. But I figured out it wasn't 12 feet because when it's area, it would be square foot.
Yeah, so linear feet, a feet is just a length, like a height, like a person can be, 5 feet, but an area is not 5 feet. But I thought that problem was a multiple choice problem, which is why.
You know what? It was. I'm sorry.
Yeah. So with that, remember, and this is something that kind of expands, your homework is very much like this too, that though in Wiley, I will tell you, part of your score is due to the unit and part of your score is due to the number. So you can get credit for one or the other without having credit for both. In Canvas, it just looks for one answer. So you have to pick the one answer. That's correct. Thanks for the input on that. Does that answer that question?
Yes.
Okay, great. Next, particular.
So I had number 20, and this one says, as of summer 2020, Voyager 1 is about 13.8 billion miles from Earth. Express this distance in AU using scientific notation with two significant figures.
Okay.
So for this, I started out by converting miles to AUs. Is that right?
If you have a conversion factor that does that, what conversion factor are you given? I believe that the conversion factor you're given might be for meters.
Yes, I think so.
Okay, in which case you would actually have to do two different conversions or you know, something like that that takes that into account. Usually there's multiple actual correct ways to do it.
Okay. So how could you show me how, or show us how you would do that? Like is there a way to avoid multiple steps? Like, is there an easier way instead of having to go through all the steps?
You can always look for an easier way to think about it. You know, all of the numbers come to the final result in the end. So any sound way to think about it, you may be doing the same number of multiplying and dividing and whatever, but some ways are easier to think about it. So our basic, let's initialize this, see if it's working. My stylus stopped working. So what's our initial number that we're looking at?
So they said 13.8 billion miles for Earth, and then it asked us to express it in AUs using scientific notations, and the final answer has to have two significant figures.
Okay. So the thing that we want to know is AU, and our distance is, did you say 13 billion?
13.8 billion miles from Earth.
13.8. And billion is times 10 to the 9, yes?
Yes.
Sometimes it's easy to mistake billions and millions. So we start off with 13.8 times 10 to the 9. And what's the unit on that?
I got.
Well, what did it give you? Was it miles or meters?
Miles.
It was miles.
Okay.
And then from there, I multiplied that. No, I'm sorry. I divided that by AUs, which is 9.296.
Okay. So your conversion factor 9.296.
Mm-hmm.
That also will have some kind of unit on it. What kind of unit is that?
I don't know. I think it's isn't it no. I don't know.
Okay. So one of the cool things is if we do get all of our ducks in a row as far as our units, the rest of it falls out a lot easier. So if we...
When you say unit, that's like in reference to like centimeters, inches, and all of that, right?
Yes, but
Okay.
with these conversion factors, and I'll actually show you how to make a conversion factor. Okay, so we have a basic fact, and this should have maybe been the one that was given to you in the problem, but you know, there are different ones out there. So we could say 1 meter, actually, this is going to be easier if we do it the other way around. We want to know basically how much an AU is, right? We're getting to AUs. AUs might not be familiar to you guys. So our factoid that we want, let's erase that, is how many meters an AU is usually. Did you guys have another problem that involved meters before it jumped to miles for you? So if you have 1 AU equals however many meters, 1.496 times 10 to the 11. So you notice this is a statement, an equal statement with units on both sides. Okay, and you guys in your math class, you may have learned, you know, your different properties, commutation, you know, distribution, all of the different things you can do in math. You might not remember what they all mean. But there's a really basic thing called the unit property, meaning, and sometimes unitary, it means one. If you multiply something by one, you get the same thing back. So the key to a conversion, or the way that I like to think of it, and you guys are free if you find a different technique somewhere else that works better for you, is to find the flavor of one that we want to multiply by in order to get the thing that we want. So if we start, and we're going to have to do a miles per meter one too, maybe we should get that fact first, and then we can actually get our multiplication factors that we're going to do. So does anyone know off the top of your head how many meters are in a mile? If not, we can look it up. So we also have this fact that we're going to need. One, and my touch screen is not the best, so sorry for the handwriting that comes out of this, guys. But 1 mile, and we're going to use MI so we don't get it confused with meters, equals 1609. And we're going to use 4 sig figs. We could keep going. It's 1609.34. But if we have 3 numbers or 4 digits coming into our problem, that's how many we want to come out of our problem. So our conversion factors, usually we want maybe 1 more digit than our data. Okay, so 1 mile equals 1609 meters. Okay, so these 2 facts are going to give us everything we need to convert AU to miles or back and forth. So we start off with this number, 13.8 times 10 to the 9th miles, and we're going to find some kind of one that we can multiply that will get rid of our miles and give us meters back. Okay, but we have 2 facts that we're going to need to use, and we're going to need to multiply it by 2 things, but we can do that all in a chain. So to get rid of our miles, and we put a little parenthesis here, we're going to put the number 1 in that parenthesis, and the number 1 that we want it to cancel out our miles, right? So it needs to have miles on the bottom. And we're kind of going to go through meters in between. So the little statement we have right here is miles to meters. So it's going to have meters on the top. And we're also going to multiply it by another kind of one because we didn't actually want those meters. That was just kind of what we had. So we're going to get rid of the meters and we're going to give ourselves AU. That was our final answer. So both of these things are going to be a version of the number 1, and we're going to use these facts to find it. Okay, so if 1 AU equals 1.496 times 10 to the 11th meters, the way to get a version of the number 1 with, and I'm going to change colors here so you guys can see me. We know we want AU on the top and miles on the bottom. So if we divide both sides by this number over here, we will get the fact that 1 AU divided by 1.496, and instead of times 10 to that, I'm just going to write a little e because that's what your calculator does a lot, E11. So 1 AU over 1.496 E11 times 10 to the 11 meters. Does everyone understand how that's the number 1? We just divided both sides here by this number. And that got this side of the equation over here is 1 now, and this side is our conversion factor. Does that make sense? All right, now the next thing we need to do is work with this fact right here. And sorry, I'm getting used to doing this, guys, just on my screen, because usually you can see me as well, and I can gesture to things. But if we have 1 mile equals 1.609 meters, and we compare that to this thing up here, where we need some fraction that's equal to 1 that has meters on the top and miles on the bottom. Okay, so we want our meters on the top, we want our miles on the bottom. So we'll just divide everything by 1 mile. And we'll end up with this side of the equation is equal to 1. 1 is equal to 1609 meters divided by 1 mile. And that's what we're going to take up and plug into here. And I'm going to erase the arrow just so we know. And so you put 1, 6, and I'm doing this kind of slow to show you guys how to think. Once you get used to it, it will be actually pretty quick and easy. But 1609 meters divided by 1 mile. Okay, so now that we've done our thinking, we just basically, I'm going to move this so we can see. We just basically have to multiply this all together. This right here is one little fraction, but it has a number on the top and it just has units on the bottom, right? This, our second one right here, has the number 1 on the top and some number on the bottom. So let's do our units first, figure out what cancels out. So we have a mile right here. Like this is miles. This is miles. Miles on top divided by miles on the bottom go away, right? No more miles. Okay. Then we have meters on the top, meters on the bottom. Meters on top divided by meters on the bottom, those go away also. So what are we going to come out with units wise? We're just going to have these AUs left over. Oops. As long as Windows security doesn't get in on us. So these AUs are the unit that we're going to come out with. So we know our answer is going to have AU. That's what we wanted, right? So when we did all this, we set it up this way on purpose to get the units that we wanted out. Okay. Then what number are we going to get? Well, we need to multiply this bit, and divide by that bit. Does that make sense? So you have multiply, multiply, divide. Okay, some people like this is breaking it down into teeny tiny steps to think through it. Some people just look at it and they're like, oh, I just multiply, multiply, divide. But if it gets any more complicated, they usually break down and they don't know how to explain it. So this is kind of the really, really detailed way to kind of show you how you know whether you multiply, whether you divide. And also if you're not given the particular conversion factor that you want, if you have 1 inch equals 2.54 centimeters and you really want to know how many inches are in a centimeter, this helps you so you know that you can just take 1 divided by that, you end up with a different number, but you understand like what goes into it. I notice people are looking a little skeptical. How comfortable are you guys with this? Is this too much, too complicated? You want a different way to think about it? Or does it make sense?
So then that final answer, it comes out to 1075.535 AUs.
Okay, so 1075 like this, sorry. It wasn't 1075.
0.535.
Okay. So the other thing that we do whenever we get an answer is, does it make sense? So our original distance that came into this was the distance to what? Like this number up here. It was like a distance out in space, right?
Mm-hmm.
Lots and lots of miles to like some star out there, right? And how big is an AU to begin with? An AU is the distance from the Earth to the sun. So do we believe that a star is thousands of times the distance of the Earth to the sun? That might be a little tricky if we don't understand like the distances in space, but yes, that's actually plausible. So the last step that we take once we get an answer is we check and make sure if it makes sense with, you know, the universe as we know it. And this does. Okay, I don't off the top of my head have the actual answer in front of me, but logically, that's something that makes sense. We can also just do a rough adding up our exponents. This is like a 10 to the 9. We divided by a 10 to the 8th. 10 to the 11th, and we multiplied by a few thousand. So we kind of know ballpark wise that might be the right size, right? If we have something that comes out to 10 to the 20 or 10 to the minus 20, and that doesn't make sense with what we multiplied together, we know maybe our calculator did something we weren't expecting or something like that. Does that make sense?
But what happens to the exponents?
Okay, so exponents add. So you can do this in your calculator, but you could also just take this part, multiply all the numbers together, and 10 to the 9th would add, and if you take 10 to the 9th divided by 10 to the 11th divided by a subtracting on exponents. So 10 to the 9th divided by 10 to the 11th is 10 to the minus 2, or divided by 10 to the 2. So you could say that a big part of that cancels out. The 10 to the 9th and most of the 10 to 11th cancel each other out and go away, and you're just left with a 10 to the minus 2 on the bottom over here. So if you're just doing an estimate of how big your numbers are, that's kind of what I do in my head, but I don't expect you guys to necessarily be able to just look at it and be like, oh, yeah, I feel comfortable with that.
So then this final, so then that 1075.53, even though that gives us AU, we still have to convert that into scientific notation, right?
Does your question ask you specifically for that?
Yeah, it says express this distance in AU using scientific notation with 2 fig.
Okay, so let's scroll down, see if we can get a little bit more place. So it just wants 2 sig figs?
Yes.
Okay, so 2 significant digits are just two numbers. So if we have 1075.53, we just want 2 numbers. What are our first 2 numbers? Well, it's this number right here, this number right here, and then we're going to have to look at this one to round. So our 2 significant figures are 11, right? This 7 right here caused this 0 to be rounded up. So for scientific notation, you put the decimal place right here after the first number. Then you figure out how many other decimal places are included. So our actual decimal place is right here. So in order to move it over to where it landed, that was 3 places, right? So that makes it times 10 to the 3rd. Magic? Makes sense. Something that you could do yourself, maybe.
Okay. Yeah, I don't know what I had done on my end. I ended up with 1.5 times 10 to the 2nd power. I think I was thinking that the total distance, 13.8 times 10 to the 9th, which includes the billion miles, times the 1 AU divided by the 9.296. And then after I did that division, I came up with 1.4845 miles. So I don't know what I miscalculated. Maybe I just set it up wrong.
Okay. Oh, okay. So who gave us the 1075.53? Because I just typed these into a calculator. Well, so in case you don't know, some browsers are and some search engines are equipped to act as calculators. So I typed this in to mine just really quick, the 13.8, the 1609 divided by this over here, and I got 148.42. So that sounds more like what you got to begin with.
Okay. Yeah, so that was
right here was just written down. Somebody mentioned it, but we will get rid of that.
Okay, sorry, that was me. I miscalculated then.
Okay, so let's back up. And this happens all the time, you know, and I don't know in advance what you guys are going to ask me, so I don't necessarily pull out the numbers myself. We just kind of do it collaboratively, but mistakes are celebrated. Like that's the one thing that actually helps us learn something new. If we just keep doing the same thing over and over again, we don't actually learn. So this is great. We did a troubleshooting, we double checked our answers, and we discovered we have actually a different number, which is this. And same thing though, we already went through our units over here and decided it was units of AU. Oftentimes the check that we did of whether it makes sense in the lab or in your classroom, plus or minus a factor of 10, you notice that. So we would have caught that in that case. In the universe, stars are everything from like 4 light years away to billions of light years away. So unfortunately, we're not going to be able to catch a power of 10 just by logic. But we look at this answer, we do the same process that we did before. We just need 2 numbers. So our first number is going to be 1. And our second number, we're going to have to look at the third number, figure out how to round it. So we have a number like 1.5, and then we figure out how many decimal places we want to move our decimal place over. So that's 2 decimal places and times 10 to the, times 10 to the is what moves it over those 2 decimal places. That's our actual answer. All right, do we believe that? Also, the check of whether this agrees with what other people got is also a pretty good check. So did anybody else do this problem and get an answer like this?
I also got the answer and it said it was wrong.
Okay.
Yeah.
All right. I will make a note. So which, is this the lab that you guys are working on now?
Yes.
Lab 1.
So this is lab 1 problem which?
20, I think.
Yeah, it's 20.
20. Okay, so that's another one that I will navigate to. If you guys want, like you have questions on this, you feel like you got the right answer and it's not working out, that's another thing, send me an email and I will check it. I'll reset it if you guys need, for this week only, if you guys want to have another try, and I can let you know if there's actual problem with the quiz or if there's some other thing that we're missing. And I've written that down also, but I will at least still check it and make sure that it's right. Okay. Do we, and since, do other people have other questions? If not, I can actually probably go look at it really quick right now.
I had question number 22. I wanted to see if the answer that y'all got matched up with mine, because the system also marked it wrong.
So 22 on the lab or 22 on the homework?
On the lab quiz 1, it says the average distance between the sun and Neptune is 4,450 times 10 to the 6th in kilometers. And then it's asking us to express the distance in AU with 2 significant figs.
Okay.
So I did the conversions and then I came up with 3.0 AUs, but the system marked it wrong.
Okay. Well, we can do a really quick check. I also get the sense that there's a few people who might not mind seeing this calculation sort of thing done again. So 4,450, what kind of units?
Kilometers.
Kilometers. So, okay, do you guys know meters to kilometers right off the top of your head, or would it be good to see that done in detail? Because I would look at this and say 4,450 kilometers is the same as 4.450 times 10 to the 6 meters. But I don't expect you guys to be able to do that in your head. So do you want to see it done? Votes, I'm seeing a couple nods. Okay, so the fact that we know is that 1,000 meters equals 1 kilometer. Is everyone good? We're on board. That's a fact that we know. So if we want a magical version of 1 that's going to fix our units for us, we want 1. We know it's going to come up here. We want the one that gets rid of kilometers. So kilometers needs to be on the bottom. We want something that gives us meters. Everyone good with that step? Okay, so That means we want to find something that has meters on the top, kilometers on the bottom. We're going to divide everything over here by 1 kilometer. 1 kilometer. We end up with 1,000 meters per kilometers equals to 1. And we stick that in there. 1,000. And this agrees. The meters per kilometers is what exactly we decided that we wanted to begin with. Okay, so if we multiply that, do we want to do the multiplication and the scientific notation at the same time, or do we want to do them separate? We can do them separate if you guys like. Okay, so we multiply it out. This is just simply equal to 4, 4, 5, 0, and this 1,000 gives us 3 more zeros, yes? And our unit with this, our kilometers will go away. We will be left with units of meters. Does that make sense to everyone? Everybody on board with that? Okay, and then if we want to convert that to scientific notation, we put our decimal right here. We know where we want it. And we count over how far we had to move it from where the decimal actually was. So we end up with 4.45, that's this bit. And the 6 is how far we had to move it over. So that's where this 10 to the 6 comes from. Is that helpful?
Yes, thank you.
Yay. Okay, do we believe it? Is this the answer we were expecting? And also, is it the answer that they're asking for, or do we need to do one more step to get it into different units?
It's asking for an AU, so I think we have to.
Oh, okay. So I was just, okay. Yeah, that's the other thing. Not get sidetracked in the middle of the problem. We want AU. So now we have meters. We should have a conversion factor for meters to AU. Okay, so the fact that we have is that 1 AU equals 1.496 times 10 to the 11 meters. Okay, so now we have something in meters. So we want a little fact that will help us get rid of meters and bring us into AU. And we have this fact right here. So if we want to get rid of meters and have AU in the end, then we divide both sides by this thing right here. And we end up with 1 AU over 1.496 times 10 to the 11 meters equals to 1. Now this is the same thing we did in the last problem. But if you guys are still absorbing this, it doesn't hurt us to do it more than once. The regular version of this lab, we actually have the whole universe, like all 8 planets, and you guys have to do the same conversion for every single one. So it's actually been carved down a little bit for you. Okay, so we take this number up here, which was actually the same as this number, right? Oops, this number. Yeah, and we're accidentally scrolling around. Apologies that my stylus is not working, guys. I know this is pretty messy, but so we have this number 4.45 times 10 to the 6 times this factor right here. So 1 divided by something is basically the same as just putting this number on the bottom, right? But we're going to leave it in the same format that we have it now. 1.496 times 10 to the 11. So this is AU on top, meters on bottom. This was meters to begin with. We're multiplying right here. Also, are you guys used to seeing multiplication look like an X? Because it also sometimes looks like an asterisk. It sometimes looks like a dot, depending on whose handwriting and what computer system you're typing in. But this is just a multiplication here. So if you multiply that, our meters are going to go away. And we're just going to get an answer in AU. Now, what size is our answer going to be?
Like, you mean like the total number of numbers?
Yeah, this actually doesn't, you said that this was like Neptune that we were looking at, right?
Yes.
Yeah, that doesn't. And what number did you have originally?
So I rounded it up to 3.0, but the number is 2.97459893.
Okay, well, that might be plausible, but I'm looking at our numbers that we have here and they are not looking plausible to me. Because we know, for example, that Neptune is more, it's further out than the Earth, right? So Earth is at 1.0 AU. So we need a number bigger than 1.0 for Neptune. And this calculation that we're doing right now is not going to do it. So we actually, what number did you have originally for the distance to Neptune? Can we double check that? That was up here.
It's 4450 times 10 to the 6th in kilometers.
Okay, so we didn't get that times 10 to the 6th here. In kilometers, we lost it. And then when we converted to meters, we've lost a 10 to the 6th. So 4.4450 times 10 to the 6th in kilometers is actually times 10 to the 9th in meters. Okay, so this is 3 times 10 to the 6th. Yeah, we're actually off by quite a bit. So this right here, I need to erase quite a bit. 4450, we forgot to mention this part, but this is still in kilometers. So if we want that in meters, it's going to be times 10 to the 9th meters, but then there's 3 more decimal places. So this right here is what we need to change. And okay, do you guys want me to show you again how to go from kilometers to meters? Because we just times our whole thing by times 10 to the 6th. We also moved it over. So this is going to be times 10 to the 12th. I might change our policy to just actually going in and looking at the actual problem because I'm not doing really well just getting verbal. Okay, so we actually have 4.450 times 10 to the 12 meters. Does everyone believe that, or are we going to find another error here? Does everyone know where that came from? We had an error of times 10 to the 6th up here at top. So we ended up times 10 to the 12th when we fixed that. Okay. So this is much more healthy. We're going to get an answer that makes sense. To propagate our fix through here, this conversion factor is still the same. Let's use a different ink. So that we still believe, but just this number is actually times 10 to the 12. All right, so we believe the answer we're going to get here. And I'm just going to type it in to what I've got so we don't have to ask people. Though everyone with calculators, this is great for you to follow along and do. What did everybody get? Okay, so what did everyone get when they did this? This calculation here. Okay, I got 29.74 AU. Okay, so your AU is what we wanted. We set this up, so we expected it to get AU. So AU is what we've got, and we've got 29.74. So the other question is, do we believe it? And then how many significant figures does your actual answer, is your actual answer asking for? And do we still need to put this number in scientific notation also?
It's asking for 2 sig figs.
Okay,
And it's
So-
just asking to express in AUs.
Okay, so if it's just in AUs and if it's not in scientific notation, we just choose our significant figures. We know we're going to keep this one. We know we're going to keep this one, but we have to decide to round. So we look at this one also, and we know we're going to round up to 30. And this is two significant figures. Now, remember when you have a 30, this 0 is significant. So sometimes we will put a decimal place after that to show it's significant, or we would write it down as 3.0 times 10 to the first, just to show that that is a significant 0 there, that it came from rounding our 29 up. Does that make sense?
Okay. Yeah, that's probably why it was counted wrong, because I had put just 3.0. And even though I had converted it into the scientific notation, I didn't notate the times 10 to the first. So then the system would either take that. No, but if it's not asking for scientific notation, then we would just have to put 30 and then the
Yes.
decimal. Okay.
Yeah, if it's just asking, if it's just asking for your regular, like this regular notation, the answer would be 30. If it's asking for scientific notation, the answer is 3.0 times 10 to the 1.
Okay.
All right, does that make good sense to everyone?
Thank you.
Okay, and I'm not in the system checking this, so I'm not exactly sure, like I can't prove that we did it right, but if you guys, I might do a little bit more of that next time. If you guys want to, I might make a form or something that you guys can enter in, like what particular questions you want to discuss before the meeting, and then I can have the different pages open so we can actually like look at the problem as written and make sure we get all the input properly input. And that will actually speed up so we don't have to wait for calculations and stuff too. Okay, any other questions?
Professor Sutherland, I just posted a question from lab, question 11, just so you could like see it. If you could open the chat box, it's there.
All right.
It's about light years and kilometers per hour.
Okay, my chat is here. All right, so that last one, the Jetsons flying car.
Yes.
All right. Okay, so we have, what are our knowns? Let's get back in having a pencil. We know V equals 160 kilometers per hour. And we know our distance is 4.4 light years. And the question is, how long? So I would express that directly into a variable that we're going to use. T equals what? So that's basically how you set up the problem. We find out what we know, find out what we don't know. Okay, so what equations would we need to use for this kind of concept? Well, first of all, we know that we're going to have to do some conversions. Second of all, we need the definition of velocity, right? Velocity is our total distance divided by our total time. Also, just a note, you guys, I just this morning added a couple different things to, I'll just show you really quick right here. Our course page down under student help and resources. So this equations and units, normally when I'm teaching in person, I actually have a big poster that I write all the equations on, and I bring that to class during your tests. So through the semester, we fill this out and add all of our equations to it. And then that's the same thing you guys have to look at when we do the test. For this class, that's obviously not going to work the same, but it is useful to start collecting your equations because you're going to see the same equations over and over again. And it's really nice to not have to hunt those down every time. So this is what it looks like when you open it. It's just a Google Doc. But these are the equations that we've used so far, and then those will be updated over time. You know, in the next chapter, we're going to have a few more equations. We have a lot of equations in this chapter. This chapter covers a lot that other textbooks usually spread out over multiple chapters. There's some notes in this, and then at the bottom also I start to explain units because I've had a lot more questions on units than usual. So I have a little blurb on the units, and then I start to have a list of the units of the things that we've studied so far. So that's just available to you. It's on the course homepage, and it will change over time with more things added to it. Is that helpful?
Yes, thank you.
Just be aware that that's there. I may have to make a separate announcement so that everyone who didn't make it gets it. Okay. So now the reason I brought that up was so you guys, if you didn't off the top of your head know the definition of velocity, you could look it up in your book, or a quick reference like that would be useful. So velocity is distance over time. People also use position, so you might see the variable x that denotes how far. Okay, so we have two different ways we could approach this. We could convert our velocity or into something that works with light years, or we can convert our distance of light years into something that works with our velocity. Does anybody have a preference? Should I pick one? I would consider it more straightforward to fix our distance first. Let's get our distance into something that makes sense. And another thing, I will actually put this into our document. My document that I just showed you, there are a few constants that will be in here as well. One of them is G. And also you may see other classes use just 9.8. I notice your homework system uses 9.81. So we'll be using that for the most part. And the speed of light, C, equals 3 times 10 to the 8th meters. So we need to know that, and that is a constant that you guys, for example, would be given on your test. So speed of light, C, this is the same C from E equals mc squared, but you guys don't really need to use that at all in this class. So 3 times 10 to the 8th meters a second is the speed of light. So basically, we need to know how much a light year is in meters, which this is the same procedure as before, but it might get messy because there's a lot of different things to cancel out. So off the top of your head, if you want to know what 1 light year is, it's the distance light travels in 1 year. So you need this 3 times, well, let's look at the definition of velocity here first. If you want to find the distance that light travels in 1 year, you need to use this equation. And you would say the distance is velocity times time. Does that make sense? So if you have your velocity of 3 times 10 to the 8th meters a second, and the time needs to be 1 year, but it needs to match up with seconds. So we need to find out how many seconds in a year. So 1 year, and then we're going to multiply it by several different versions of 1 in order to do this conversion. Okay, so 1 year, we're going to have 1 year on the bottom and 365 days on the top. Does everyone understand that that's 1? We're just multiplying this by 1, right? 365 days over 1 year is just 1, right? We also need to get rid of the days because we don't want days. So this is going to cancel out with our years, right? We don't want days either. So 1 day is 24 hours. Okay, we don't want hours either though, right? So we need to get rid of the hours by choosing something to multiply. So we're going to put 1 hour. We know that there's 60 minutes in an hour, right? This is the worst conversion ever as far as complexity, but these are all facts that you guys have in your head, right? So hopefully you can see that however complex your conversion gets, as long as you follow the basic tools of conversions, you guys could do this by yourself. Okay, so our days are going to go away, our hours are going to go away. Right now we're sitting at minutes. We don't want minutes either, we want seconds, right? So we get rid of our minutes. Ugh. 1 minute, 60 seconds. So if we multiply all of this together, we are going to find out how many meters are in a light year. Does everyone understand how that comes to be? We have how fast light can travel right here. And all of the rest of this is how you convert a year into seconds. If you don't happen to know off the top of your head, which I don't, how many seconds are in a year? Okay, so if we do multiply this together, 3 times 10 to the 8th times 365 times 24 times 60 times 60, the answer that we will get is 9.46 times 10 to the 15. Just so you know, this C came in as 3.00. The speed of light is actually correct to 3 sig figs. So we kept 3 sig figs here. If we really just had 3 and nothing else, that would only be 1 significant figure on our input, and we really couldn't claim a whole bunch of sig figs on our output. But 9.46 times 10 to the 15th meters is a distance. A light year is a distance, and we've just converted that into meters. Now, if we wanted to double check ourselves, how many meters are in our light year is a fact that the internet knows. And if we asked it, we should probably get the same number that we calculated. Now, this could vary, right? Technically, if you take the average of all years, including leap years, there's 365.25 days in a year. And if you had multiple years, that would average out. However, our year, right, is just 365 days. So this number can vary just a tiny bit for things like that. But if we ask meters in a light year, they will give us the same thing that we have. So we know that we did that correctly. Okay, so we now have a great conversion factor. This is meters per light year that we can use to decide how many meters we can go. So if we have 9.46 times 10 to the 15th meters per light year, we multiply that by this thing right here, which is just one of our inputs. So this is times 4.4 light years. That means the total distance that we want to go is 4.16 times 10 to the 16 meters. Does everyone believe that? Did anyone find any errors as we went through? So this is our distance. Okay. So there's one more little mismatch here. This was given to us in kilometers per hour, and our distance is now in meters. we are going to, in general, be always doing distances in meters. Even when we use astronomical distances, everything like that, meters are going to be the default for us. If you're on planet Earth and you're used to velocities on planet Earth being in kilometers or miles, more likely, we're kind of used to that. But it's going to be generally best to do things in meters. And oftentimes, if you just get all your units into our standard units, and that little blurb I showed you did explain a little bit about our standard units. If we use standard units, it actually makes things really easy as we go along. So the best default is to change this into our standard units. Now, do you guys want me to show you how to do that again? Or are we to the point that we can kind of do it in our head a little bit? 160 kilometers per hour. Now, does the fact that there's a per hour on the bottom of this and that it's a velocity, does that confuse us when we're used to converting distances? That unit on the bottom, well, two things. That unit on the bottom being hours, we are gonna maybe need to fix that if it's not asking us for our answer in hours. So that is going to kind of need to be handled later. But the kilometers can be handled on the top, can be handled just like any old kilometers. This unit on the bottom can just tag along for fun right now. So if we want to know how many meters this is our velocity. Move down here. This is a velocity. We want to get rid of kilometers. We want meters. So what do we know? 1 kilometer is 1,000 meters. Right? So you end up with, we're running out of space, but we will just go down. So V is now 160 plus these 3 zeros, 0, 0, 0. And what are our units going to be? We cancel out our kilometers. We end up with meters per hour, which is not ideal. We would prefer meters per second, but we can either change it right now or we can get our answer out at the end and change it then. What kind of answer is your system asking you for? What units?
It's asking for it's multiple choice and it's asking for like how many years.
Okay. So let's go ahead. We just found this number for how many meters are in a light year. This one for how many meters an hour we can go. We're going to get a time in hours. And then after we get that time in hours, we can convert it. Okay, so this is not just light years. This is our total distance that we're trying to travel. So we can go back up to this equation right here. You guys see where I am? Your distance equals velocity times time. So we have distance, we have velocity, we want time. So what do? We're gonna do a little bit of algebra on this equation, right? We want to solve it for the answer that we want. So that's T is equal to distance divided by velocity. Okay, so T is equal to D, which is right here, divided by V, distance divided by velocity, equals, and we can just type this into our calculator or our whatever we're using. 4.16 times 10 to the 8 is 16 divided by this velocity. And we are getting 2.6 times 10 to the, let me count it up real quick. 1, 2, 3, 4, 5, 6, 9, 10, 11 times 10 to the 11, but we also need to keep track of our units. Granted, you guys, this lab is all about how messy our units are. So apologies, but you know, these are our skills that we're building. We need to keep track of our units and make sure that our units are correct at the end. So because we had meters an hour, and we ended up with hours here. This divided out. The meters divided by the meters canceled out, but nothing on the top divided by hours on the bottom gave us units of hours in the end. So almost there. One more conversion. We need to know how many, you guys said years, how many hours are in a year? So if we look at this conversion that we did up here, we just don't have to worry about this part, right? But the logic is the same. So if you want to know how many hours are in a year, you have 365 days for 1 year and 24 hours in 1 day. So you would multiply this by the same thing, 365 days per year. Actually, it's actually going to be the reverse, right? Because we want to get rid. Ignore what I just did, you guys. So this is always our logic that we used before. By writing our units down first is going to be most helpful here. So we have units of hours. We want to get rid of them. So we have to have our hours on the bottom. And then what do we know? Well, we know how many hours are in a day, right? So the 24 is going to be on the bottom. The days are going to be on the top. 1 day over 24 hours is a version of 1, right? And our hours are going to go away. But we don't want days either, right? So what do we want? We want years. So we want to get rid of the day that we just got. We want years on top. So 365 on the bottom and 1 year on the top. So do we believe that this is also a 1? Does this make sense to everyone?
Yes.
Okay. So, and then we're scrolling by accident. So then to do this calculation, we have our 2.6 times 10 to the 11th hours. Then we need to divide by 24. And then we need to also divide by 365. All right, and the answer I get there is 296,80365. So big number. So we're going to, as we go, convert it to scientific notation. Let me see. 2.968. So if you guys need a different number of sig figs, you're going to have to choose different ones according to however many you need. And then I'm going to add up the decimal places here as I see it coming out of my calculator. It's times 10 to the 7. And that's in years. So if we compare our number in hours to our number in years, our number in years is going to be smaller, right? Okay, do we believe that? Do we see any mistakes? Does it make logical sense? All of that.
Yes, I got that.
Okay, so, and then the big picture with this question, 160 kilometers an hour is really high Earth speed, right? That's about as high as you could do in a good car or something. You know, way higher than any legal speed to actually travel on roads. So the cool thing about this problem is it's trying to illustrate, you know, Proxima Centauri, 4.4 light years is the closest star to anything we have. We have our sun, which is 8 light minutes away. We have Proxima Centauri, which is 4 light years away and a bit. You know, it gives us a little more significant digits. So this is how long it would take you to go to the nearest star, not just, you know, a regular star, but the very closest star of any star to us if you were traveling Earth speeds, which is a very long time, right? Millions of years, tens of millions of years. So that's one of the big points of this problem, is to kind of help understand the scale of the universe and how it's so much bigger than anything that we really handle on Earth. All right. Does it make sense? Do we believe it? Does it, any more further questions about what we did here? And like I said, I'm sorry that what comes out is kind of messy, but hopefully as you guys were here and had a chance to follow me along as I did that, the chicken scratch doesn't matter quite as much as understanding the idea, what happened. Any further questions?
I just had a quick question on the lab quiz for number 23. It's asking us how long it takes light to make a trip to the Earth, from the Earth to the moon. And so I just Googled it and I had put 1.3 seconds, but I was wondering, I don't know if is that what the question was asking?
You know, it probably, it should have given you some kind of number. Oh, this one, I actually split up a question that was there. So you need to refer to number 23 and the other one together. It actually gives you the distance, and it was the distance, it was referring, there was a whole scenario. It's referring to the 60s when the astronauts were there and they put a mirror on the moon. So these two questions go together, and I think it actually says refer to the previous question in that question. So
Yeah,
it's not just the distance to the moon, it's the distance to the moon in the 1960s, which it did change a little bit, and that whole scenario when they put a mirror on the moon.
Because I just took that number and then I used that numeration for number 24, but it still prompted that number 23 and 24 was wrong. So I think I don't know, I miscalculated somewhere.
So it's going to be pretty close, but you need to use the numbers that they give you for that. It's not going to be exactly the same as what you would get if you Googled it. Okay. And in general, this was supposed to be a calculation. So you were supposed to use the numbers that you were given and not what just generally out there on the internet. Okay, so does that make sense, or do we want to pull it up and talk about it at all?
I think if we can just get like an idea how to word the problem, because I understand what she's saying. I feel like it just gives you like the 2.63 seconds.
Uh-huh.
I know that you have to convert it.
Yeah. So and I do think so. The whole point logically, and I actually tried to simplify this problem a little bit from the way it was originally written. So I'm given materials from the school.
Mm-hmm.
And I think the original problem just said, oh, the astronauts went to the moon. They measured this time of 2.63 for a light beam traveling to the moon. How far is it from the Earth to the moon? And then it's like, and why did you have to divide by 2? And a lot of times people are like, what? Dividing by 2, where is that? So I think that the first thing we do is say, if it takes, if you send a light beam out from the Earth and bounce it off a mirror on the moon and it comes back, and the total time is 2.63 seconds, units of seconds equal to time, then how long does it take just for light to get from the Earth to the moon? So that's where your divide by 2 comes in. We have you do that first because it's actually a little easier. Students in the past were really confused. So if we start off with 2.63 seconds for a round trip, a one-way trip is just half of that. So that's what we start off with.
Oh, okay. Oh, okay. I get it.
Okay, so our initial time for a one-way trip from the Earth to the moon is 1.135 seconds. Now, the beautiful thing about this problem compared to all the light year problems that we did before is we started off in our SI units.
Mm-hmm.
We want meters and we want seconds. So we don't have to mess with any other conversions. We can just use the basic speed of light, 3.00 times 10 to the 8th meters per second. That's a fact that we know, that's the speed of light. If you were in a test or something, I would give that to you as a constant. And this is velocity, right? So we are given this, well, we're given this time first. We're just supposed to use basic logic to get this time. And then we have the same equations we talked about last time. Velocity, the definition of velocity is distance over time, or any, basic math on that you would want. Okay.
But here the question is just asking for us to put that 1.315.
Okay, yeah, so if you put your 1.315 seconds, and if it specifies how many sig figs you want, but the first thing is you just need your time.
Yeah, okay.
Okay, and then the next problem is the one that asks the rest of it, right?
Yeah.
Okay, so, and the answer to the question here is how far, right?
Yeah.
So what variable out of these ones right here, what variable is that going to be?
Well, we're trying to find distance, so that means that we have velocity at time.
Yeah, so if we want distance, what do we need to do to this formula? We just need to take the t to the other side. Distance equals velocity times time. And the velocity is the velocity of light, right? Which is this thing we have right here. And our time is the thing that we just figured out in the last problem, which is right there. So we just need to plug those both in.
I'm wondering if the system marked it wrong because I just left it at 1.3 instead of putting 1.315.
Probably if you have, okay, so, and I'll have to double check. If you get, if you have 3 sig figs going in, you see we got the 2, we got the 6 and the 3, all of those are significant digits. You need to keep that many at least as you go.
Okay.
So, and I believe if you put 1.3, you should, if you round this to 3 sig figs, this one would actually round up. So the system should accept 1.315 or 1.32.
Okay.
But if you don't, if you just put 1.3, that's, you're losing information that you once had. You don't want to do that.
Will the test be timed? Like how, I don't remember if we talked about that.
Okay, we haven't talked about that yet, and partly is this course has never been 100% online before. Usually the lab part of it is on campus, and then we like shift the exams over and have them during the lab period. So I have emails out to my boss and stuff, and we've trying to find out exactly what format people have talked about, lockdown browsers and different things for the exams. So I'm trying to find a solution that's fair and that works for everyone. I just don't want somebody takes the test, the answers get out on the internet, and then everyone else takes the test a week later. Like that's just not cool, right?
Yeah.
So the exam will probably be just in a limited window. So like it might only be available for one day. But within that day, you guys have the freedom to fit your exams in, where they fit in your hours. And if you want to devote a few more hours than other people to the exam, then that's probably fine. I'm really sorry for not having those policies up front, but this is new. Yeah.
Please give more time. Always I'm slow. I need more time.
Yeah. Well, we do try to keep it fair to all the students in the course. So whatever amount of time that, any of the students have, all the students have that. If there's learning disabilities or something, you guys need to work with the Access Center. And then I get a letter about accommodations. So anybody who needs accommodations, go to the Access Center, talk to them, and they'll send me a letter and you'll get whatever accommodations that you qualify for. That's just legally a thing for learning disabilities. But otherwise, the policy will be the same for everyone. And it will be like a day for the test.
Will the test be timed like to where once we enter it, we have to finish it, or will we be able to, do it in bits and pieces? And will we be able to use our notes?
I think we'll limit it to like one sitting. It will be open notes, but it really is, cheating is an issue when we just, have everyone out in the wild doing whatever they want. And so, yeah, it will, you need to find a block where you can sit down and devote the time to it.
So as long as we start the test and we finish it, like even if it takes us 3 hours to finish it, like will we get that time, or will the time be set by the department?
They have not given me any limitations right now. Okay.
I'm just worried, I'm really worried because this doesn't come naturally to me. So it takes me a really long time to have to actually process, and I'm not by any means a physics major, and this is only an intro class. So the last math class that I took was in graduate school, but
Yes, exactly.
it was not science related. So a lot of these basic functions, I've had to come back and doing all the conversions and all of that, it takes me longer than normal for somebody that's already majoring in it or that's used to seeing it.
I'm right there with you. I'm not by any means, good, not good, but with numbers or math or anything, equations.
Yes.
So it takes me a while. I have to go back and
So if it's any comfort to you guys, I do try to make, like I mentioned, the calculations that we did here, where I'm showing you how to come up with what's a light year from scratch. That is more complicated than anything you'll see on the test. I usually, on the exams, I just want you to logically know all of the equations in that equation list. You should know how to use those. But if you look at them, I will pull them over so you can see them. These are all equations with 3 variables in them for the most part. So I try to keep the math, and that's the point of a conceptual class. When I was an undergrad, I literally had tests that did, it took everyone 3 hours or 4 hours because it was an engineering class and just the math was that complicated. I don't want anyone to die from the complications of math. That's not what the class is about. But math, on the other hand, is the language of physics. You guys need to be able to do some basic calculations and basic conversions. But these labs are more complicated. So the lab, normally when it's on campus, is scheduled for 3 hours a week. So that lab that you did, it's not a crazy thing if it took you 3 hours, that's fine.
Okay, good.
But
yeah,
the
because I feel like it took me forever.
Yes. So those labs, and like I said, normally when we meet on campus, you also are working in groups and I'm there. So if you got stuck or something, you wouldn't be permanently stuck. But the lab, it's usually, I don't know if you guys have heard the little, in university courses, you're supposed to spend 2 to 3 hours out of class for every hour it's in class, and that's an average for a typical student. So the lab is considered 1 credit hour and it's scheduled for 3 hours, and you're supposed to only need up to 1 hour out of class to prepare for it. And then we actually sit and we work together for 3 hours sometimes. So that's kind of the scope of the lab. So the 1 lab assignment that you have per week, that's about how much, kind of as a maximum. The course ends after 3 hours and you need to be done by then. This class, actually, we try to go easy on you, and oftentimes it's quite a bit shorter than that. But there are a couple assignments that might run that long, and that's not out of the question, and you shouldn't feel bad if it's taking you that long. The homeworks are kind of variable for students that understand it well and don't find it too arduous. It shouldn't be that bad. But the rest of the course is a 3 credit hour course, meaning that normally we would see each other for 3 hours every week, normally in 2 or 3 different lectures. And then you might have 6 to 9 hours of homework to work on. So the homework part and the discussion questions are supposed to take about that long. A lot of times people aren't used to those kind of expectations for university, but I've been hearing this since I was a student. I had a lot of teachers tell me that. And oftentimes we're kind of on the light side of things, but don't feel bad if it takes you a lot of time to process it, because you're doing, with just your reading, you're doing the part that we would normally do as lecture together, that we would be together for 3 hours. Plus there's the 3 hours that you would be maybe with me or another teacher for lab, as well as all the regular amount of homework that you would do for a class. So I think that this class might be a little heavier than some other classes, but it has just ordinary college rigor to it, really. So hopefully, does that help? We
Yes.
don't intimidate anyone, but also this is kind of a cool class, and I've had people shake my hand and say, wow, I didn't know I could do this, and I've just learned so much that I didn't know before. So it's a lot, and we try to support you and make sure that nobody needs to be intimidated or anything. But also that, yeah, you do learn a lot. It is a lot.
I think you doing these Zooms are really helpful, because just seeing it on Canvas, like in words, trying to explain the computation of like the extensive math that's involved, especially like if you're not familiar with it, is just more confusing. So
Yeah.
Thank you. These to me are a lot more helpful when they're live.
We'll try to do Zooms like most weeks probably, and feel free, to let your voice be heard in the questions when we have the questions and announcements on Canvas, to say, oh, hey, but that is the thing. It is hard. Normally, at least there's a lab that we meet together, and to me, the math works well as whiteboard work, that I could get up and show you the steps of going through the math problem. And our little paint whiteboard here is a little sad compared to a real life whiteboard, but I'm glad that you guys find that useful, and hopefully it will continue to be something that you can absorb, even though it's messier to look at than a whiteboard would be. Is there anything else that we want to go over conceptually? Anything like that?
Will you be sharing that form where, like, if we have any questions, we could just add it to that form?
I think I will, just because otherwise, we have all of these announcements, and I've noticed that there has been a little bit of inefficiency coming in here and trying to get, someone to read the question. And if I don't write it down exactly right, it gets messy. So yeah, I will create that, and definitely it will be available at least a couple days before the Zoom next time. And then we can just go off a list.
Are you going to keep the Zoom meetings the same day, Sundays?
You guys can give me feedback on that. What do you think? My negatives on that would be, if everyone is not equally available on Sundays, then it's a little bit less fair. But I do think giving you all the maximum opportunity to look over and work on the homework yourself, and then still, plenty of time afterwards to finish up once you've been able to get your questions answered. I picked that because I kind of view that as optimal timing. But I could see how some students would argue, hey, if I'm not around on that day and time, then that's not very nice for me. So what do you guys think?
I mean, for me,
Good time and day, for me at least.
It works for me unless my oldest son has tournaments for basketball. So I was gonna ask if you, because I remember there was a message where you were asking us for different options. Like, will you have one day Sunday and then a second option like throughout the week if we needed to?
Okay, well, we don't want the number of hours, because a lot of time we post these videos and then the other students that weren't here, they're left with hours of video to slog through, and it's kind of hard. So normally what I was thinking is once a week, but maybe not have them the same time every week. Like maybe we'll do, and like I said, I do want to keep it kind of close to the deadline, so you've had a few days to work on it yourselves. But we could also maybe say, oh, hey, for people who can't make it Sunday morning, your questions matter too. So maybe we'll have it, I don't want to go late on Saturday because people might have plans, but maybe like 3 p.m. on Saturday one week. and Sunday morning another week. Or if somebody, you know, maybe the lab is really confusing one week and people want to have a lab one or something instead. So I'm flexible, but I do think that there is something to be said for having it near the deadlines.
One of my old professors had us do like a vote, and whatever the majority, like whenever the majority of the people were available on a certain day, that she would do that day. So I guess, I mean, every week we could just do like a, hey, if comment like, or in the discussion board, and you just reply down below if you're available this day, and we'll do the majority, and then
Yeah, well,
watch
yeah. There's a couple points on that. One is if like 3/4 of the class is available on Sunday morning and 1/4 of the class never is, then I would rather have them on Sundays 3 times out of 4 and have something different, you know, that at least every once in a while, maybe, you know, if there's a test every 4 weeks, then maybe at least once every 4 weeks, then everybody has a chance to make it, kind of thing. And then the other thing is when I did kind of post in the comments, I mean, we had so many different options and different people, different days. Like if I tried to make a calendar even to sort those answers out, it would actually be pretty complicated. So I do think that maybe making a poll, but I also think you know, if people have work or whatever, and if they can say, hey, I've got a Zoom every Sunday morning, maybe they can actually adjust their schedules. And if it's regular, then that's something that they can plan on.
Yes, I think Sunday morning is good.
Yeah, so probably, and just because I know all of you guys managed to make it this time, so I would probably open it to the class, but I'd probably take it down, make it more simplified, maybe bring it down to 3 or 4 options. Maybe we would have a vote, but it would be nice to say maybe half of all of them will be on Sunday mornings. So, you know, if that's good time for you, or, you know, if it was on Saturday night or Saturday afternoon, then you will know that you will have that available, at least to look over what everyone else asked by Sunday morning. So you still have, you know, a good amount of time to work on the homework or whatever. I'm starting to get just a little hoarse. Does that still seem fair to everyone? And then, you know, like I said, we'll involve the rest of the class because this is only a minority of us here.
I do have one question just about my grade. I don't know if I've got that here. It's kind of a simple question.
Yeah, grade stuff is usually a little more personal. So if you can send an email, that's probably better. And then, like I said, I know a couple people have said, you know, we want to go back and look at, you know, a couple questions, make sure the system is grading them right. Or maybe now that you guys, and I think I did a blanket statement. I know everybody is on a learning curve. You all are figuring out the system and how much detail you need to give it. So basically just message me if you want your questions reset. And for this week, I'm just taking requests on that. And I'm willing to reset Wiley, or I hope Canvas has a similar option that I can just let you guys try again if you got stuck on just due to the way that the system wanted to have it from you.
Professor Sutherland, I had already sent you mine. Do you want me to resend the questions?
I believe on yours, I think I already did that. They were Wiley's questions, right?
You reset it on Wiley's, but these in particular were for lab 1.
Okay, so I don't believe I got that email. I will check, like if it's come in, you know, since I last checked my email or whatever, I can do that. Otherwise, I haven't seen another one. I believe I already did the ones that I got. So if it was like this morning, I will still get that and I will do it. Otherwise, go ahead and send it again.
Yeah, it was late. Like I want to say it was probably like midnight when I sent it.
Yeah, I might not have that. Let me.
If not, I can just resend.
Yeah, and then like any personal questions people have on their grades or whatever, I'm happy to do those by email or what you need. And I know this call is getting kind of long. It's going to take a while for the video to process. Are there any more physics questions that we have? Any more general questions, how the course works, how the navigation works, anything like that?
I have a quick question about the grade book. I don't know if anybody else's looks like mine does, but like lab 4 through 8 says it's missing because it was like due in like June and July of 2020.
Yeah, so some of these things are imported into the different systems from other things that were set up.
Okay, so
Yeah, the labs, some of the labs were originally created at other times and for other courses, and they may have been edited or whatever, but we imported like the Canvas little course format. We imported that from some other semester. Canvas is really weird and wonky with dates. And I've had no end of students be like, well, on Canvas, it said that assignment didn't have a due date, so I figured I didn't have to do it. And you guys may have noticed that I've made multiple assignments that are like, hey guys, get these in, they're due. And people are like, but it still says no due date. So Canvas itself, the due dates are sometimes a little bit weird because it just depends on when the lab was created and by whom and for which course.
So like we could still press the link, and we could still complete it.
Yes, so don't worry about those. I will adjust, and of course, if the grade book is messed up and it's not accepting submissions from anyone, that will affect the whole course. So I tried to double check the first several weeks of the course and make sure that they were all in order, but I may be doing some fine tuning and tweaking and stuff the rest of the semester, so there will be a few changes as time goes on. But don't worry, I am aware that there's some weird dates in the grade book that need to be fixed.
Also, what is like the chapter 1 through 15 adapted practice?
Okay, so that is content that came from Wiley. Wiley made it up. They provided the textbook. And so it's just kind of an extra that comes along with the textbook that as you go, you can just check and see how well you understand it. So it'll ask you a question and it will judge how long it takes you and what your confidence is and everything. And it will kind of rate you on how confident you are. A lot of people will find that useful, like when you're going to study for the test. And you maybe have done your homework and everything, but you just want a chance to go over the concepts and see if you're as comfortable as you should be. The adaptive practices are useful for that sort of thing. I believe that they imported into my Canvas just to give you access to them. They are not worth points. Like I don't assign them to you. You don't have to do them for credit, but it's just another resource.
Do you know how to get to those? Because I was trying to figure it out, but I don't think I could find them.
Let me look. If you just click on it, you should be able to get through to Wiley from it. Like I thought that those links, the reason they even existed was so you guys could just use them to get in.
Well, like I don't know if there is a link to them because I was just looking at them on the grade book.
Okay, so I might make that visible. I can see them under assignments, but I think that you guys assignments are not in your navigation because we're trying to make those. Okay, so I'm checking that now just so you guys know. I know you can't see what's going on with that, but here I can show you guys what it looks like to me. So I may just make another module for these to live in, but it gives an instructive view. That's an instructor's view. That's not going to help you guys. I'll just check that. I'll make a little note on my to-do list. And if you guys can't see those, I will try to move them somewhere where you can see them so you can get to them. Normally, the learning systems I've used before, the equivalents to Wiley, you can navigate around the course and you can see the extra practice and stuff once you already get into Wiley. But I noticed here they want you to navigate in Canvas and then you just click through the one homework and it only takes you to the one homework and stuff like that. So I'm not completely sure how the navigation works, but if I need to change something on Canvas to make it more available, I will try that and see if it works and continue to work with it if it needs help.
I don't have any more questions, so I think I'm good.
Okay, is everyone good?
Yes, ma'am.
Anyone else? All right, last call for questions. Like I said, personal questions for grades or specific things that need to be reset for this week only, go ahead and email me on that. But thanks for coming out, guys. Hopefully it was useful to you and we will keep in touch. Thank you.
Thank you.
Thank you, Professor.